Hello, my name is Kimberly Reiner, and I'll be going over chapter 6 today. So, we learned 6 lessons in this chapter. So, the first lesson was TCP and UDP protocols. Both TCP and UDP live in the transport layer of the OSI model, and basically, the transport layer's job is to manage data delivery between applications on different devices. TCP establishes a connection between devices before sending data, which ensures that all packets arrive safely, packets arrive in order, and lost packets are transmitted. Some examples of TCP applications include web browsing, email, and file transfers. So what UDP does is it skips the formalities. There's no connection setup, acknowledgement, or retransmission. It's designed for speed over reliability. Examples of UDP applications are streaming video or music, online gaming, and calls. So if we use online gaming as an example, if you have a few packets, uh, if a few packets drop, like quick updates, in a game, it's fine. Like catching up matters more than resending. The lesson two was the TCP three-way handshake. TCP is connection oriented. It must ensure both devices are ready to communicate, and without this process, data could be sent to a device that isn't ready, which can lead to packet loss or confusion. And basically, there's 3 steps. There's synchronize, acknowledge, and acknowledge. Basically, the two devices sync up, and then they both acknowledge each other and give each other the a sequence number. And then they confirm it, and then after that handshake, data transmission begins. And so this matters because it ensures synchronization between both systems, confirms they're both ready and reachable. Then it also prevents duplicate or out of order packets during the communication. The third lesson, we learned the DHCP process, aka DORA. DHCP automates configuring configuring the device's IP address, subnet mask, and gateway, so therefore we don't have to do it manually. There are 4 DHCP steps. There's discover and offer, request, and acknowledge. So discover is basically where the client broadcasts, is there any DHCP server there? And then the offer step, the DHCP server would reply with like, yes, I can give you this IP address. And then the request, this client can say like, great, I like to have that IP address. And then acknowledge, the server basically finalizes it saying like it's confirmed. The server would also send a subnet mask, default gateway, and DNS server address. Each DHCP address is given for a lease time, which is like borrowing it for a while, and like it has an expiration, and the client would renew it. Um, and if the device disconnects for too long, the IP goes back into the pool so someone else could use it. In the fourth lesson, we learned automatic private IP addressing, aka a PIPA. It's a built-in fallback mechanism used by Windows, Mac OS, and Linux systems. If your device can't contact a DHCP server, it assigns itself an IP address in the range 169.1.254.0.1 to 169.254.255.254. The subnet mask would be 255.255.0.0. Um, and then there is no default gateway since there's no route to the internet. Um, Basically, this ensures your device can still communicate locally even without internet access. And if a PIPA activates unexpectedly, uh, check the Ethernet cable or Wi-Fi connection, make sure the DHCP server or router is up, and you can also run ipconfig slash renew. That's Windows, or sudo DH client for Linux or Mac. Um, and then the next lesson, lesson five, it's DHCP relays and the IP helper address command. So routers don't forward broadcasts by default. So if your DHCP server is on another subnet, the broadcast won't be able to reach it, and the client won't get an IP address. Um, then that solution comes with the DHCP relay agent. It acts as a middleman. The client sends a broadcast, and then the relay agent intercepts it and forwards it as a unicast message directly to the remote. And then the DHCP server replies back to the relay, which sends the response back to the client. And then the IP helper address command to enable this be on Cisco routers to enable this behavior, it would be like IP address, and then the DHCP server IP. And then the sixth lesson, we learned about the domain name system. So computers communicate using IP addresses, and DNS is basically like the phone book, and it can translate names into IPs automatically. Without DNS, like you would have to basically memorize every IP address. So this just basically automatically does it for you. The DNS hierarchy, so like using it's like an upside down tree, like if you use the example www.google.com, the dot is the root domain, com is the top level domain, Google is the second level domain, and www is the subdomain or host name. Then there's fully qualified domain name. This is a complete address of a host on the internet. Um, all levels included, and that example could be like mail.example.com. Um, the that training dot often, which is often hidden, represents the root of the DNS tree, making the name fully qualified. Um, And then some common DNS record types. There's a record, which is address record. It maps a host name for IPv4 address. And then there's for a record. This is an IPv6 address. Um, so basically it maps a host name for an IPv6. There's CNAME record, which points one name to another. And there's the PTR record, which is the reverse lookup for from IP to host name. And then there's the MX record, which directs email traffic. And that is it.